Yo, the name is Sir Jow, and today I'll be talking about recursion. Random video, I know, but it's whatever. I want to preface by saying that you do not need to know Python to know this. Python is what's being used for the examples in this PowerPoint, so that's the only reason I have it up here. Other than that, recursion works with any language. It doesn't really matter. So without further ado, let's go. So I first want to start off by saying that when I was learning recursion for the first time, it was pretty confusing for me. I was like, what in the world am I looking at? So for that reason, I'm going to try to break this down as simple as possible, and hopefully I'm successful at doing that. So the main premise of recursion is to repeatedly call a function until a result is achieved. However, it is very inefficient. If you can use a while loop, a for loop, or anything else, then use that. Recursion should be the last resort, and unless for some odd reason it's the only way to achieve a result, which I highly doubt in most cases. So there are two main parts of a recursive function. You have the base case, and then you have the recursive step or the recursive call. Those two are very important. Let me elaborate. So we have this function called add up to, which takes in an integer for the one and only parameter. And what this basically does, it adds up all the numbers from 0 to the number that you input. So if you input 5, you end up having 0 plus 1 plus 2 plus 3 plus 4 plus 5, which I believe that goes out to be 15. That's what this function does. And as you can see, it's a recursive function. So under the method definition, you see the line if num equals 0, return num. That will be the base case. That is the condition that ends the recursion. And without a base case, you would have an infinite loop and you will run into an error. As you can see here, recursion error, that is in Python. I'm not sure with other languages, but in Python, you will run into an error. So in this case, the base case for this function is whenever that num parameter becomes 0. If that is the case, you return 0, basically. And also notice the usage of the indefinite article a. That implies that, yes, you can have multiple base cases. It depends on what you're trying to do. Then under that, you have the recursive step or the recursive call, where you return the call of the function within itself and pass in different arguments. So in this case, because we are adding up the numbers from 0 to the number that you input, we're doing num plus add up to num minus 1. So usually when you do a recursive step, usually adding to something, subtracting from something, multiplying from something. You're usually doing something. You're changing something for the most part. So yeah, these are the two main important pieces of recursive function. Now, we also have to understand something called a call stack. A call stack is a queue of operations waiting to finish. For example, so you have two functions, as you can see there, and you run this snippet of code right here. When each function is called, it is added to the call stack. Once they finish, they are removed from the call stack. So when a function is being ran, you will see it in a call stack. You'll especially see this if you're debugging and you'll have a call stack somewhere. You can see what's being ran. Like for example, in Java, you have to run a main function in order to run a program. So if you look at the call stack, you will see main. It will always be in the call stack until the program ends, which is usually when the call stack is empty. So yeah, so you must understand call stacks. Important thing to know about these call stacks also is that they are last in, first out, meaning the last function call added to the call stack will be the first to leave the call stack. So the very last function to be added to it is the first to go. This is evident when calling a function within another function, and this is extremely important to know when doing recursion. Let's do an example real quick. So say you had this code on the right, and we're going to call function 1. So we're going to run this code real quick. So what happens? First things first, please notice on the left, the call stack. You see that func1 has been added to the call stack because we're now running the code inside of function 1. So this first line is addition equals 1 plus 2, so that's 3. So when you print the addition, you have 3 on the console on the bottom. Then this next line we're calling function 2. Now, just like we discussed, every time you call a function, it'll get added to the call stack. So that's exactly what happens here. On the left at the call stack, you can see function 2 has been added to the call stack. And of course, we're going to print I'm alive in the console here. Then function 2 disappears because we are no longer running function 2. So it is no longer in the call stack. So we're going back to function 1. So now we're going to print addition times 2, which is 6. And then we're going to do integer division. So if you do 3 divided by 2 and then floor the number, that's 1. And then, boom, you're ending the code and the call stack is now empty. And like I said earlier, typically when the call stack is empty, that means the program has ended. As you saw in the previous slides, a function is added to the call stack whenever it is called. Also notice how function 2 was the second function to be added, but the first to leave the stack. So yeah, like I said, the last function to be added into the call stack is the first to go. So keep in mind that a function can appear in the call stack multiple times at once as well. That is very important to know with recursion. That is literally what recursion is. It is a function that keeps going in the call stack. You can see function one, function one, function one, function one. You can see it all. Now let's look at a very common example of recursion. If you know math, you should know the factorial function. What this does is basically, you know how I mentioned that add sum, that add up to function earlier. It's basically like that, but you multiply and you do not include zero. So 5 factorial, for example, is 5 times 4 times 3 times 2 times 1. So yeah, that's basically what factorial is. Now let's identify the parts of the recursive function. So we have the base case, which is this if statement here. If num is less than or equal to 1, then return 1. So that is the base case. This is what ends the recursion and gives us a value of 1. Then we have the recursive step. So we multiply the current number with the return value of the number before the current number. So the process repeats until the base case is met. So if our number is 5, for example, this will be 5 times factorial of 4, which actually makes sense because 5 factorial could be rewritten as 5 times 4 factorial. So yeah, let's go ahead and find factorial of 5. Let's go ahead and do that. So on the right is the code, on the left is a call stack, and on the bottom we're keeping track of the number, the current number. So let's go. Let's run factorial of 5 so that we can print it. So our current value, our current number is 5. Is 5 less than or equal to 1? No, it is not. So we go to this line right here. Return 5 times factorial of 5 minus 1, which is 4. Therefore, we're going to run factorial of 4. And as you can see on the left, factorial of 4 has been added to the call stack and factorial of 5 remains. Always remember that Python sequentially runs lines. So it waits for a line to begin to end its operation in order to go to the next line. So that's what recursion basically is. So is 4 less than or equal to 1? No, it is not. So you go to the next. So now you got 4 times factorial of 3. So now we're going to run factorial of 3. And we're going to keep doing this until we get to factorial of 1. So now we're at factorial of 1. Is 1 less than or equal to 1? Yes. So you return 1. This, ladies and gentlemen, is our base case. This is what ends the recursion. So now we have factorial of 1 equals 1. So we're going to do something called backtracking. So you see this call stack, right? Remember that it's basically bottom up when it comes to order. So we're going to backtrack. So we're going to go from factorial 1 all the way back to factorial 5. So notice how factorial 1 disappeared from the call stack, and now we're back to factorial 2. Now that we have the value of factorial 1, we can finally complete this line right here. Return 2 times factorial of 1. Well, factorial of 1 is 1. Therefore, factorial of 2 is 2 times 1, which is 2. So now we're done with that call. Now we're at factorial 3. Now that we have factorial 2, we can finally complete this line right here. So we have 3 times factorial of 2. Well, factorial of 2 is 2. So 3 times 2 is 6. And you basically keep doing this until you reach the end. So you have 4 times factorial of 3, which is 6. So 4 times 6 is 24. And finally, factorial of 5. We know that factorial of 4 is 24. Therefore, this is 5 times 24, which is 120. Then you print the result, which is 120, and you end the code. So that, ladies and gentlemen, was factorial of 5. That is the process behind running a recursive function. It keeps on going until it reaches the base case. And then once it reaches the base case, it does something called backtracking, and it basically goes back in the call stack in order to complete the function calls. So yeah. And as I mentioned earlier, in Python, if you are simply calling a function within itself with no return statement, any code that follows will be ran when backtracking. Because again, this is because Python sequentially executes code, meaning it executes code line by line. So if you're not returning anything, once it backtracks, after it runs that line, after it runs that function, it's going to then run anything that comes after it if you don't include a return. So yeah, so I really hope I broke it down enough. I apologize for the stuttering and stammering I've been doing this entire video, but I think I got the point across. If you have any questions, ask me and I can try my best to answer it for you. So yeah,